Hello everyone, it's June the 6th. Alright, doing it pretty early today. Very fresh. Let's see. This seems to be a difficult one because the passing rate is 37%. It's almost a difficult one. And also because it's very early in the day, 97, so that could play in it as well. And I don't remember about this at all. Alright, let's see. Given S1, S2, and S3, find whether S3 is formed by an interleaving of S1 and S2. An interleaving of two strings is a configuration where they're divided into non-empty substrings such that S equals S1 plus S2, blah, 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 T equals T1 plus T2, blah, 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 and N minus M smaller equal to 1. So N and M is almost the same, so it has to be almost the same. And the interleaving is S1 plus T1 plus S2 plus T2, blah, 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 all the way, so either ST, 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 so you're either ending with T or S, or TS, 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 you're ending with T or S. So example 1, we can say AA, DVBC, BC, AC. Ah, nice. Okay. Could you solve it using only OH2 length additional memory space? Well, let's not consider the memory space at the moment. This most likely is, I don't know, a DP. You see the 100 and 100, which means it allows you to do ON square, ONM, right? This gives you ONM. So if it's ONM, then it's most likely DP. We just need to figure out how we can do DP about it. So one is AABCC, the other one is DBBCA, right? So what we can say is we want to find out whether, or maybe like all possible interleaving. Let's say dpij, okay? Let's say dpij is a set containing all possible interleavings. So, if that's the case, then to compute dpij, what I need is dpi minus 1 and j minus 1, right? So dpi minus 1 and j minus 1, if I know, let's say ABC, dbbc, and then we have a C and an A at the end. So what do we say? Well, that's actually not right, because if it's the last one, wait, hold on. Interleaving, we have to divide it into the same number of pieces. Then it can change, right? Because the last one, I could combine them together. Oh, okay, this doesn't seem to be... Maybe we need to configure all? So we have 100. How many different ways can we configure it? There are a lot of ways. Yeah, I don't feel like DP. Oh, hold on. Yes. Yes. So if we go I minus 1, j minus 1, that means we want the last one to be an individual, right? Individually, so whatever we have, and the last one, I don't know, I mean, we can go C first and then A, or A first and then C. Can we do that? Because previously is interleaving, so it follows this, right? So it follows, I mean, we can put a flag saying which one is first, right? Is it 0 or is it 1? If it's 0, then we have to not which one is first, like the current one, right? The current one, and then we just put the other one and put the other one. So that's fine. We can definitely do that. So we can have this, but in addition to that, might as well you just not do I minus 1 j. What's dpi and j minus 1? dpi and j minus 1 is dpi, which all the way here, and then j minus 1. So like this and this interleaving, right? And then we add this. Oh, you have to consider all of them. Because now what we're thinking about is for each new pair, right? Because we have many different ways, right? If you are at the last one. Now, if you're at the last one, it's going to be dpi, and the last one, j, you want to add this one in. So you can, I don't know, add this, right? So we have all this and all of them, this and this, right? Then, so we add a 1, or we add 2, but it could be, man, I just have a lot of possibilities. Didn't feel right, right? Which one goes from S3? Because S3 is the end, right? And all we need to know is if S1 and S2 can make S3. So we can match S1 and S3. We can match S1 and S3. Can we do longest common subsequence? S1 and S3? If we can match. Well, we also need to fulfill the requirements that it has to be an interleaving. So the question basically is, if we do a match between S1 and S3, and we find all the pieces, and does the remaining piece form S2? That is the question, right? But what if we have many different choices to match? I mean, this is a trivial one because the start is A, and we'll have A. Thanks to A, and now we go to D, so we have go D, DBB here, and then DBB, and the next one is C. We'll keep matching C. The next one is B. We have to match B, C, and then A and C. Yeah, so this is an easy thing. Like, what if we have the S1, S2, and S3 all the same? That's going to be difficult. Well, because it must be part of SA, or S1, part of, so SA, S1, S2, S1, S2, or S2, S1, S2, S1. So maybe, is that backtracking? We just arbitrarily say we're gonna go with S1 first. Okay, and we try to match. If it doesn't match, then we go S2 first, right? And then when S2 matches maximum, we always do maximum match, and then we match S1. And okay, so we match S2, we'll go maximum match, and then once we don't match, we will go S1. And then if match is successful, then successful. If it fails, then we'll match again, but this time we don't go maximum. Or we can just match 1, and then we try to match S1. And then we'll go back, and we'll go back, we'll go back. Maybe it will work. Maybe it will work. What I'm saying is, we just S1, we match the first, right? And if it match, we just immediately match S2. And if it match, we match S1. Whenever we failed, whenever we fail on this match, we go back, and then we just try to match 2 characters, right? And then if we match 2 characters, we go do it again. If 2 characters doesn't match, then we will match 3 characters, match 4, match 5, match 6, all the way match the end. And if it still doesn't match, we go previous. Oh, what is timeout? I have a feeling this might time out, but we should try this. This one doesn't seem easy at all. Okay, let's try this. We might. So I'm thinking about can we DP it? I mean, what are we doing? We're saying we're matching at a certain, when we call the function, right? When we call the function is to match at a certain index for a certain thing, right? So let's say DFS, right? And we have the index, which is on S3, and then the current is S1. So the current matching is that S1, right? Is that S1? Actually, no. We'll just put. What will be the better one to handle this? Let's just is this one. That's fine. So true. That's just Boolean value. So this one will just return a Boolean value, right? Right, and then in DFS, so we're gonna go at current, right? And now we say S will equal to S1 if is S1 else S2. So get an S, and we have, we need another index. So index, and we'll call it I and J. So I will be pointing to S3, J will be pointing to whatever S1 is 2. So we got these, right? And then we're gonna say While, I don't know, while, no, index S3 and then index S3. So, and then we call I equals index, J equals index S3, okay? Now, what do? Now we're gonna go forward. While I smaller than len s, all right? And j is smaller than len s3. If si is equal to s3j, if these two are the same, then we say we're going to DFS j plus 1. You know what? Let's swap these. Okay, so not j plus 1. We say I plus 1, right? J plus 1. Ooh, I plus 1. That's not I. And so we don't know where the other one stops. So we have to say, oh yeah, my. So have S1 and then index S2 40. That's 4. Okay, Si equals S1 index S1 if else S2 index S2. And then J will equal to this. All right? So I is the one to compare, right? I or J, I is the one to compare. So I compare them. If they are the same, then holy guacamole, this is not right. Oh, this is not right. Hold on. I, K, J equals index S1, index S2, index S3. Okay? We say if is S1, then we say if S1 I is equal to S3, then I will need to move forward, J, and then K doesn't move. Let's move forward, and this will be false, right? And we say if this is true, then return true. Otherwise, so I plus equal 1 and j plus equal 1. So we try that again, right? If it's still the same, then we do it. Another one, do it. Else, if it's not, right? That just means from this one going forward, we can't. Like we have exhaust, right? So if it's the same, and then if it's not the same, right? Not the same, then we need to do this again, right? So we need to do this again. We do this again, right? We do this again. And if it's true, return true. If it's not, right? If it's not true, that means we have exhaust everything, and then we shall return false, which means I have matched everything I can with S1, and then none of them returns a good value, right? None of them return a good value. So So if they not return a good value, I need to return a false, which means this matching is false. And if this come out, would it come out here? Oh, it might. Just keep going, keep going. Then if it come out, that just means, let's say, S1 has matched completely, right? So it's like we match, and then we just keep matching, keep matching, keep matching, keep matching, and we keep matching to the end. But we do S2, and then it's just not working, then we shall return true, right? That just means, let's say like there's no S2, we exhaust S2, and then we just keep matching, right? Keep matching. And yeah, what happens if you match the entire thing? To match the entire thing, just empty match, say a match, then we'll return true. I think we do return true here. Which means, oh, but this one will not, because if this one match, right, and then we try to match this, and this one is at exhaust. At exhaust, I should return false, right? If it exhausts, I should return false. To force this one to keep matching, keep matching, keep matching, because at a certain point, it return false. Only when this entire thing, right? Only when this entire thing and of course this is just one. If exhaust, so we probably should do it here, right? I'm gonna say if index is 1 is equal to, but no. Oh, we do it this way. If index is 1 is equal to len is 1, right? So we shall return S2. So S1 is already exhausted. Hold on. If is S1 and index S2 is equal to len S2. So S2 already, and it's S1's turn. Then we shall return S1 from index S1 to the end equal to S3 from index S3 to the end. And then if not is S1 and S2 equals len S2. No, S1 equals len. So not, so we are at S2, right? And then we should say index S2 to the end equal to S3, index S3 to the end, right? So when we do this, and then we can handle this, then we can say when we're at the end and we don't have anything. Because if K at any point K exhausts, then we shall return this value directly. So we don't have to worry about it. So I think this one shall be false. Because if it's true, we already returned true. Okay, so that's if this And then, yeah, we can, let's just say else, it's fine. So it will be J, no, it will be K, right? K is this S2K, and then I doesn't change, K will be +1, this one will be true, and then K plus equal 1, and this one, same thing, I, K plus 1, true, okay, and then when we call DFS, we start with 0, 0, and a 0, and let's just call it true, which is, we have to do true, and then we have go DFS 0, 0, 0, false. I have to call it 2 times, because at one time am I, so we return this or this, depending on which one we go first. And just from func tools, port, value cache, let's cache this function. All right, we have very simple. Let's see if this one can handle. If you can't handle this, there's no point in moving on. Man, Lord, this one is tough. Yeah, I still don't know if this is false or true. When there's a go on to the last one, remaining false. But no, I should be fine. All right, so we have S1. All right, S2, S3, S1. S1, S2, is interleave. Try it. We passed the first two, but we failed the last one. I say it's true, but actually it's not. So we'll do AA, and then DBB. Can do B, and then we fail. Hold on. So let's say so 0, 0, 0, right? And then so I can match so index 1. This is 0, try to match this, which is false. And then the index is 1, and the index is 1. 1, 1, 2. So index 1, index 2 is 0, so K is 0. So if this is equal to, no it's not. And then we go try to do, so this is not the same. K and J is not matching. If it's not matching, we should not move this forward. And we shall not move K forward either. Because K and J, we have one that's not matching, right? So we move forward and then these two are not matching. So we need to go back and go back, right? So we go back, move one back, and try I. So in this should be the same. We should move back. Maximum recursion. Oh yeah, we just keep calling the same thing. So what happens when they don't match? So we're trying to match the two, right? So boom, they don't match. They do not match. Let me think. So past K and J, we say we want to start matching this and this, and boom, they don't match. Okay, if they don't match, we need to call. So whatever the I is, try to call the I. So we call I. Yep, plus equal 1, plus equal 1. And then they match. Then we try go the next one, right? So yeah, that's the first one they match. Then I need to move forward. J move forward and try to match this. And now this does not match. Right? This one does not match. And then we shall match I and J, which is true. We shall go I and J. Why will we have just trouble? Hold on. Three, 3, 6. We're stuck at 3, 3, 6. We're stuck at 0, 1, 2, 3. 0, 0, 1, 2, 3. 0, 1, 2, 3, 4, 5, 6. 3, 3, 6. So the true doesn't match. Now we go to false doesn't match. Which means at this point, nobody matches. Shouldn't that be the signal that, that we shall escape? It doesn't match. Which means we haven't moved anything. Then we go there. And in here, we also doesn't match. So every time we don't match, we need to go to the other one. And we need to compare, right? So this is when we pass in. We pass in this. And then we try to match, okay? And then we try this. Now we pass in this, and then we fail to match. And then we basically return. Now the thing is, when we're passing in, that means, let's say matching this, we try to match this, it doesn't match, so I want to pass into this. And then when I match this, and it doesn't match. And when it doesn't match, we can check how. Yeah, we just have a case that it doesn't match. So IKJ. So I call this, and then it doesn't match. So I call IKJ again. This, and then this doesn't match. So I call this again. So like they're just calling each other. how do I signal that this is so like it's my turn, but I cannot match. So I say, okay, you continue match. And then come to me and I'm trying to match, but it doesn't match. If it doesn't match, shouldn't I just say, no, what, I cannot match? I shall return. Like if I can match, perfect. If I cannot match, right? Which means if I cannot match, like I cannot match at all, that just means, yeah, it shouldn't just be if I did not match, right? And then say if I is equal to index s1, which means I didn't even move forward at all, then I'll return false. Otherwise, we can try. Here's the same thing. We say if j is equal to, j doesn't move forward. Okay. Let's comment out the print. Yo, I don't know. This one, I feel this one's going either timeout or worse. Oh, I solved it the last time. It will be very, very bad if we cannot solve it. Nah, this is not looking good. Timeout or error. Time limit. Ooh, I solved it the last time. Damn. What was it? What was it? Ooh, what do you do? What do you do? This is like brute force, right? And then it times out. This is brute force. Gotta be a better way. Or we can try greedy first, right? So this was like not greedy. We match one, we try to match the other. Or we can try greedy first. What if we greedy? What does greedy means? Oh, greedy just means we will try to match as much as we can. Once we cannot match, we go for the other. And if other works, perfect. If other doesn't work, then we backtrack one, right? And then we backtrack another one. We backtrack. And every time we backtrack, we try it again. Backtrack, try it again. Backtrack, try it again until we exhaust. Then we say, okay, let's try this one more time. Kind of, yeah, a greedy kind of approach. What do we say? We say if it's this, and then we say while s1i is equal to s3j, we're going to go I plus equal 1, j plus equal 1. Ooh, don't forget. Right? So once we're done, we jump out. And then we need to backtrack, right? Backtrack. We just say, so we have a current I, right? And when you use the current I to try j. So let's say for I in range from the current I back to index s1 minus 1. So we just tracking backwards, right? So we say if DFS II, right? And then K and J. Yeah, because we match into this J. Oh, for T. No, that's too complicated. So this one shall be J minus, right, I minus II. So initially they're the same because it's a 0, right? So the point is every time we go back, then the K needs to go back, right? Every time we go back, the J needs to go back as well. So how much we need to go back is from the I minus, okay, so this is the J, and it's going to be false. So if this is true, then we return true. If it's false, we just try again, and at the end, we're going to return false. So that's the first idea. Okay, and this, I will say we can do the same thing. We say while K is smaller than S2, that's fine. S2K is equal to, then we go K plus equal 1, blah, 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 and then this will be for KK in range from K to S2, and we take, this is going to be I, this is going to be KK, right? And then we're going to try, say, K minus KK. And then we say we're going to go true. And if it's good, otherwise, and then we do both again. That's true. Okay. Try it. Oh, ooh, that's maximum recursion, man. Of why? Are we hitting here? What happened? So, okay, in this case, we go AA maximum, right? And then for I is pointing to, I actually pointing to B, right? And then K is still at this position. So I, K, and J minus 0. So J is going to be at this position. Okay. Then we will match DBB. Okay, DBB. And then next one doesn't match. Okay, so now we're gonna go try to match the B and then B. So these two match, then we hit C and A. Okay, so we go here, C and A. So C and A doesn't match. So K doesn't move forward. Okay, K doesn't move forward. So KK. So let's do the same thing. We're jumping back and forth again. So we need a check as well. So we just say, if you ask me to match, but I didn't match anything, then I shall return false, right? Okay, so we say if I is equal to this, then we'll return false because I'm not matching anything. Right, and then here is the same. We say if k is equal to this, then I'm not matching anything. What? What happened? What the hell happened? Two to four. 0, 1, 2, 0, 1, 2, 0, 1, 2, 3, 4. We're adding this B. 0, 1, 2, 0, 1, 2. Oh, they're both. Wait. So input is 2, 2. Let's say 2 to 4, and is a true. Okay. So these good, so they move forward, and then hold on. Okay, where am I? So they're matching. So I plus 1 and j plus 1. So I will go to 3, 0, 1, 2. I will go to 3. J will go to this, and then they're not equal. And then, okay, so this one skip. So I will be 3, right? And then, doesn't matter. So it's going to be 3. K is going to be 2. And this is going to be, J is going to be 3. Wait, what? How is it not? This is bonkers. Two to 4, 3 to 5. Yeah, we go to 3 to 5. And then we go to 3, 3, 6. We go to 3, 2, 5. We go 3, 2, 5, true. And we go back. Ooh. And we got stuck. Yeah, this is convoluted. I don't think that's the actual solution. I don't know, man. See, 3, 2, 5. What's 3, 2, 5? So 0, 1, 0, 1, 2, 3. 0, 1, 2. 0, 1, 2, 3, 4, 5. 3, 2, 5. 3, 2, 5. We try to match 0, 1, 2, 3, 2, 5, and it doesn't match, right? 3, 2, 5, we find this one, no, it doesn't match. Then we become 2. Become 2, 2, 4. Yeah, 3, 2, 5 doesn't match. So we go 2, 2, 4. I try to throw to that. But this one has been counted already. Because it's 2, 2, 4 false. Okay. And 2, 2, 4 false. 0, 1, 2. 0, 1, 2, 3, 4. Then they move forward. Doesn't write. I try to call. 2, 3, 5. 2, 3, 5 true. So we call back to 2, 3, 5 true, which end up at 2, 2, 4 true. Yeah, okay. 2, 3, 5. Can we detect that it's kind of in a loop? So when we say it's in a loop, then we just exit. I don't know. No, this doesn't feel right. I don't know. This is tough. This is very, very tough. Strain is always tough to deal with. I just don't have a clue, like a good idea how to proceed. All right, we're gonna go to solution. This is not gonna work. Recursion with memo. It is 2D DP. How come I couldn't figure out 2D DP? This is not 2D. This is like ND. 2D DP. Okay, let's try it again. So we know it's 2D DP. Like what? Does it contain? Like what am I supposed to DP for? I want to see from this to this and this to this. Do they contain this? Right? What I was trying to say is we can have, but that's not true. Do they contain I plus j? Well, we can try. We say dpij is equal to true if S3 I plus j, S3 all the way to I plus j can be formed by interleaving S1 all the way to I and S2 all the way to j. How about let's make that our idea. So we will want to get dpij. We want to get the last one, all right? So we can say, let's look at dp, I don't know, I minus 1, j minus 1. So we look at dp I minus 1 and dp j minus 1. And if it contains this, right? We're thinking about the last position. And if it's the previous position contains this, then we say, well, it's the last one, but how do we know it follows? So do we also have to consider the last thing, right? What is the last thing? Hold on, let me think. Let's say we have the last thing. So I can say, okay, I use these, I can check, I will know, right? If it contains, then perfect, I got it. If it doesn't contain, let's say, how about dpi and j minus 1, and dpi minus 1 and j, so we consider, no, like that. Then, okay. Maybe that's enough. Consider ij minus 1 and ji minus 1j, right? If an interleaving of this fits, then we check this. If interleaving this fits, then we check this. If this doesn't fit, and this doesn't fit, hold on. If this doesn't fit, this doesn't fit. Interleaving. It doesn't really matter, right? As long as interleaving, I can always add the current one. It doesn't matter. If we start with this, if I end with this, I just add one more, which is fine. If I end with this, we just add one, that's fine too. So no matter what, it's going to be fine. So all I need is, if this is init, interleaving, and if this, hold on, let me see. What are we saying? I threw all these things out. This is just ridiculous code. Okay, so what I'm saying is, I want to go at a DP table, right? And then we say length 0, 0, right? And then we can say this one grows, and then this one is, if this one's not, then we try so what are we saying? Hold on. We're trying to find this. We need this, and we need this, right? So we're trying to find this. We need this and this. Try to find this. We need this and this. Try to find this. So what we need is first. So this from the second row, all I need is this and this. So in the first column, so I need to produce the first row and the first column. Okay. Then what we can do is those will all be false, right? Empty string and empty string will be true, all right? So let's say this is S1, this is S2, and then for each S1, the row, and S2 is a column, right? So this is the empty 0 length, 1, 2, all the way to the length. So up to 1 length, we try to match the whole thing. What does that mean? Is that like this S1 have no contribution? S1 is 0, so S2, right? So we can do that. We can say dp equal to false times, let's say len is 2 plus 1, okay? And then dp0, it'll be true, okay? Because that's a 0, that's all empty. And then everything else, I mean, and then dp, I don't know, minus 2 shall equal to S2, so that's like the entire S2 length. So it should be len S2 equal to, oh, I should be S2 equal to S3, right? Because that's the entire thing. We're trying to match the entire thing. Because with no help from S1, right? With no help from S1, S2 we want to try to match the S3. So that's that. And then we're going to say for I in range from 1 all the way to len, S1 plus 1 is S1, the length that we contribute, right? And for each one, dp0, right, which is equal to this, dp0 shall equal to with no S2 help, just S1. So S1 I equal to S3, right? And then for J in range 1 to len, S2 plus 1, right? So now S2 has contribution, okay? So we have some S1 and some S2. Now what we're trying to say is, does, because now S1 has some, and then S2 has a little bit more contribution from S2. All right, and then for this, we're gonna say shall be dp, right, j minus 1, right, dpj minus 1, and dpj, right, dpj. So dpj shall equal to dpj minus 1 if it contains, and then if it doesn't contain, right, if it doesn't match, and my current, if previous one doesn't match, and my current, even if it matches, it's not going to match. So it has to be previous one has to match, and so this, what is this? What is this? This is, wait, hold on. What are we looking at? We're looking at the ij, right? We're looking at ij. So contribute this, and j contribute, S1 contribute this, S2 contribute this. And it has to be dpj minus 1, which means I contributed. So we want looking at j, right? So it has to be S2 j equal to S3 I plus j. I'll have to minus 1 because these are all lengths. All right, so it has to be this or dpj. Right, dpj is previous, so we contribute j, contributes 2, so we have to contribute s1, which is I minus 1, equal to s3 I plus j minus 1. Oh, yes, because that's I is length, so there's the current length, and then I plus j minus 1 is S3 at the current length. Wait, hold on. We have S1 length and S2 length plus together and then minus 1. So we just say dpj equals this, blah, blah, blah. Then we can return dp minus 1. That work? Oh, lordy, this one passed. First one doesn't pass. That's okay. I feel like I'm on the right track, but I need to. It's all false. The hell? How is that possible? Hold on. We have this one's A B C C, A B C C, D B B C A, D B B C A. Of course, we need to extend one more, which is the empty. Shoot. D B B C A. Okay. So initially, shall do the initial one. So I'm gonna print here. That's the initial DP, right? So we have initial will be, this is always true, and then the thing we want to match is AAD BBC BCAC. That's the thing we want to match. So what we have is false, 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 because without A, it doesn't work. Okay, so now we say we have one A, and we don't have, so this is actually true, right? Wait, hold on. This is with one A with no B. Hold on. dp0 will be this equal to no I plus j minus 1. Hold on. The I plus this one. What the hell? J referred before. This. Yes, that's the thing I was talking about. Well, maybe, no, this is the first one I was trying to, maybe I can, I don't know, maybe I don't have to, maybe I can just go this, right? But hold on, so J starts with 1. A can start with 0. Yeah. So I can start with 0. So I start with 0 and now this I'd rather do it this way. I think this way is fine. Okay. I remember I have this thing. I don't even know what this one returned to. That shall be true, right? Because it's just the same thing over and over again. What the heck? Index out of range. Okay, if -3 is not equal to -1 plus -2, then return false. Yep, this is lordy, this is false. Try this. Now, I don't think I solved it by myself last time, but yeah, who knows? Try it again. Wrong answer. Okay, what the hell? Let's see. No, I'm not worried. We're already at this stage. It's fine. Output false. Expected is true. Okay, let's draw it. So what we have is, that's a 3 by 3, AA and AB. We want to make AB, AA. Okay? So what we want to make AB, AA. So we can do AB, AA. Ooh, are we saying? Say this one is go A first, right? S1 first. Huh. Okay. Well, I'll do it this way. Def dp S1, S2. Alright, and now return a Boolean value. Do this, and now we say return dp S1, S2, or dp S2, S1. How about that? How'd you like me now, huh? How'd you like me now? Alright. It's a little bit trick right there. 走你! Come on. Come on, this shall be right. Oh yeah. Oh, we did solve it. I consider this by ourselves, and I did go straight for OM. I'm gonna call it ON. Space complexity. So I say that's by myself. Let's see. How did I solve it last time? I have a strong feeling that last time I didn't do it by myself. I was just very late, so I decided to do it, and then kind of going back to it afterwards. Otherwise, you see, this is 5. I didn't end until 7:30, right? So I think I didn't solve it in the first time. It is DP. It's just how you configure DP. It's always this, right? DP is always like this. It's not very difficult to implement, but it's very difficult to figure out. How to configure the DP. So I almost gave up on this one. Got a hint from the solution that I shall use DP. Now, what is the target of DP? Right? So it turns out we can make dpij be a Boolean value, right? A Boolean value indicating whether interleaving S1 all the way to I and S2 all the way to J can form S3 I plus J minus 1. Actually, we should say I, J. No, I can't. Where I and J are the lengths of S1 and S2. Lengths of S1 and S2. The length of this one is 2, right? Now, if dpij, right, is false, then no matter what we try to match next, it's not gonna work. If dpij is true, then we can hold on. Now to find dpij, we check dpi j minus 1 and dpi minus 1 j. Right? If any of these is true, right, then we compare hold on. If any of these is false, right, hold on. It's hard to say. If dpi j minus 1 is true, right, then we want to compare S2 j with S3 I plus j minus 1. Since dpi j minus 1 is true, right? Since this is true, we can as long as S2j is equal to S3 I plus j minus 1, we can always append S2j and still make the interleaving work. However, if dp I j minus 1 is false, or s2j is not equal to s3 I plus j minus 1, then interleaving won't work this way. And we have to check the we have to check dpi minus 1 j. At the end, we have to also go both ways, right? Making ij matching s1 s2 and ij matching s2 s1. In all is omn with on space. Man time with on space. Lordy, what a tough one. Okay, so 103, I think that's from a year ago. Oh wow, look at this, beautiful. I feel like this, I wrote this myself. N1, N2, N3. The heck is what is the length? So 3 lengths are the same, is only 0, 0, 0, right? Okay, so we say if I3 is equal to N3. What's I3? Oh, I3 is equal to N3. And those two hasn't, okay. If I1 is smaller to N1, okay, and S3, I1 is smaller to N1 and S3 is equal to S1. So these two are the same. Then we help her. Oh, this is almost the same as what I tried to do, but this one works. Mine earlier attempt does not work. And then we say I plus 1. So we're trying to say what is the state. We have 3 states, I1, I2, and I3. Isn't I3 always I1 plus I2? If you think about it. Oh, this is actually very nice. I'm gonna try this. Okay, so oh. Okay, well, we use this N1, N2, and N3. Go to line S1, line S2, and line S3. Okay. Then def DFS, helper. I1 and I2. This is what I think. I think only need 2. Okay. We say if I1, I2, I1 plus I2. Okay. equal to, and 1 and 2 and 3. Then return true. I don't think I need this. It will never be the same. It will only be the case. We'll say if n1 equal to n2 equal to n3 equal to 0, then we return true. That's the only case I was trying to do. Because other than that, there's no other case that will fulfill. Otherwise, we'll always have to check, right? So we say if I1 plus I2 is equal to N3, and I1 plus I2 so we hit the end, and I1 smaller to N1 or I2 smaller to N2, then we'll return false. Yes, because it's not enough. Too long. So we can say if this, right? And then we say if N1 plus N2 is not equal to N3, then we return false. Then we don't need to do this. They will always match. So these are like kind of two initial conditions. Then we say, right, if I1 is smaller than N1, and so we're matching S1 to S3. We say S1 I1 is equal to S3 I1 plus I2. I1 plus I2. Well, if that's the index, and we have the index 0, 0, heavy 0. Hold up. 0, 1, 2, 3, 4. 0, 1, 2, 0, 1. Yeah, we should make that. I'll make that L, the length. So it'll be length is smaller equal to, and this one minus 1 is equal to length 1 plus length 2 minus 1. Alright? So with that matching, we're going to match the next one. We say if helper L1 plus 1 L2 is true, then we'll return true. Did we just return false here? Z2 smaller equal to N2 and S2 L2 minus 1 S3 L1 plus L2 minus 1. If helper L1 L2 plus 1 return true, otherwise return false, and then return false. So it's like if I match, then we try matching again. If I cannot match, then we call it. Because you will always have to match the current, and then we move on, right? It's either match or it doesn't match. It has to match. If it doesn't match, then we return false. All right, then in that case, we can say this, this, and this return true. Okay. And then say and this, return true, otherwise return false. Then we say return helper 0 and 0. And let's do diario cache. Let's see. Nope. Strain index out of range. L1 is larger than N1. And L2, let's say, how do we handle that? Now, we should do, I don't know, if L1 plus L2 so if L1 plus L2 is equal to N3, right, that means we have reached equal to N3. That'll become too big. That's why I always say it's out of reach. And every time we keep moving on is because we have the previous one is equal, and then I move on to the next one, right? So if this is larger than, that means, I think that means we should return true. Try it. Shouldn't be start for 1 and 1. Nope. It should be 1 on 1. Because 0, the case is already considered. How come? One plus one, two. 2 minus 1 is 1. Ooh. Shall go for index, right? The length. We do need a3. Really? I feel like that's not pointing to the first one. That's why we have the issue. Because L2, when we start, we started with a 1. So both, I say, contributing 1. But actually, 1 shall contribute. So I think we shall start with 0. But we need to write another code, which is now, I don't think this one will hit. Okay, so I think if L1, if 0 larger than, how about this? And 0 larger than this. Oh, initially we'll return 0, 0. Neither is moving. So if both are 0, or should we say this, or helper 0, 1? It doesn't make any sense, man. Right now it's 1. Oh, 2 is 0. So 1, I'll say, okay, these match. Then that'll be 2, right? Still match. 3. So L1 now I come to 3. So 3 and 3 doesn't match. So false, right? And then 2 right now is 0. And I return false. Man, I do have to. Huh. I do have to have another one. I really don't like this, but I do have to have an I3. Okay, so now we can just say if I1 smaller than N1 and is equal to, now we have is I3, right? And helper, I say I1, I2, and I3. That true. Otherwise, it'll be the same thing, but this will be I2 and S2, and I1 don't move, I2 plus 1, that return true. And then we call becomes a 0 and 0. Ooh. Oh, and 0. Ah, this is still not right. Alright, let's see. What did I do? Oh, I forgot to I3 plus 1, my bad. Yes, I3 need to plus 1. Because I move on for the next one. Still not right. Okay. False. The first one. Oh, the only thing we're missing is this, but I don't. You're kidding me. Alright, you're kidding me. Is this one really that important? Oh, shoot, it is. That's the, isn't that the. Yeah, this is the end. Oh, yes, this is the end condition. And now we don't need this. Ah, this is the anchor case. Oh, yes, this is the anchor case. They all reach the end. All three of them reach the end. Man, this is my solution from a year ago. Much smarter back then than the solution I have today. Well, better is in terms of it's just interesting. You write it out. Yeah. Okay, so it's almost an hour and 45 minutes. Oh, I didn't see if we. Oh, we got more test cases. Okay. Actually, this one is the right way to do it, right? This one is DP, and then we go at 2 rounds, and then, yeah. Oh, unbelievable. Come on. Did they do it? Yeah, I run it 2 times. I think they only run it 1 time. But I think overall it's the same. And it's easier just to say we go at once and then we do it 2 times. Alright, that'll be it. I will see you guys tomorrow. Adios.